what you just heard was the start and the end of a process. The sound clip played was generated by our program, and Colin, an amateur composer, was able to take that seed of inspiration and turn it into his own short, unique song. We are Ripple Music, and we streamlined musical composition by creating a program which can generate melodies for users to take as foundation for their songs. I am Marcus Lezzi, this is Austin Small, and this is Colin Lezzi. Austin, with his background in computer science, took the lead role in the construction of the software for our project. Colin, with his background in systems engineering, developed the model for the music generation. And I, with my interdisciplinary knowledge, was able to translate that model into workable code that I could work on with Austin. The validation for our project idea really came from an initial survey we sent out to composers. We found from this survey that the composition of a short song takes approximately 3 to 7 days, and the majority of that time came from the key pain point, the creation of the melody, and we wanted to support this. We believe we have developed a solution to this problem. Ripple Music, a creativity assistant, develops a unique, personalized melody, short melody, for the user to build and creatively make their own. And we found that it is quite efficient. It helps a lot. The melody generation period, using this from beta tester feedback, has shown that results have changed from 1 to 5 days as the expected length of melody generation to just under 5 hours. For example, for this song, learned it yesterday because I used it at 12 p.m. was the first time I hit the button, and after 2 hours and 37 minutes, I had created the song that you just heard. So, what did this look like at the start when we were conceptualizing the project? First, we knew that we wanted to use a web-based application. This was because we wanted to make it accessible to as many composers as possible. Second, we wanted to accept user input for our program so that we could tailor our melodies we generated specifically towards their needs and what they liked. Remember, what we're doing is we're assisting them. We are giving them creative work to work off of, and we are making it so that they enjoy the process as well. They want to make things that they like. Next, we allowed an output in the form of a MIDI or MP4. This is so that the users could seamlessly integrate our product into their current composing journey. This is because they use, like me, a MIDI keyboard or GarageBand or some other computer application. Finally, we used machine learning to discover rules and patterns in the genres we focused on to develop melodies that already have key ideas that are made in industry today. With that, I would like to show you a live demonstration of our project. As you can see and hear, this is the front-end environment of our creation. You can hear an ambiance, an ambient background noise of rain, which is provided to the user so that they can feel more at ease, more relaxed in this frustrating process. But we give people, as we will now, the option to turn off the background noise to focus on the melody. In case you don't know what you're doing, we have a help function, but luckily, as we are your guides, we won't need that in its entirety today. So, what are we going to do? Well, we have a plethora of different instruments offered, but we're going to choose flute because, one, I play the flute, so I like it, and two, it's best for the speakers to be able to hear it. Next, we are going to select the chord, and that will be C minor. We will select the genre, pop, and this defines the probability distribution of our product. And then we will select the chords C, A flat, E flat, and B flat, which will each play for one measure in length. And for those of you who recognize this, this is a very common pop chord progression. And then we'll select a tempo of 75 beats per minute. And finally, we will choose triple meter, which means our output will be in 12/8 time signature. And we will generate a melody for you. As you can see, we create the sheet music for the user to be able to read off immediately. We also add a replay function. We won't play that for you now, but let's say we are not satisfied with this output. If we hit generate again with the same exact inputs, our program will develop an entirely new melody for us. Finally, to show off the versatility of our project, we're going to quickly change it up a little bit and switch from pop to classical, which changes the rhythm selected as well as the probability distribution of the melody generation. We are then going to switch to C major, because I like classical in C major. We are then going to select a tempo a little bit faster of 105 beats per minute. And we're going to select duple meter instead of triple, so we will play in 4/4. And we will generate chord progression. Oh, yes, chord progression, excuse me. We will choose C, G, A minor, and then F major. And because it's fun, we'll do it one more time. This is currently live, so in your own time, if you want to toy with it, please feel free. Music by Ripple.com.
With that, let's take a look at what's happening behind the scenes. The user begins by selecting several inputs. We take those inputs, and we probabilistically generate the notes associated with the melody. Simultaneously but independently, we generate the rhythm associated with the melody. Combining rhythm and notes, we have a melody. Next, we generate the chordal accompaniment. That is, the chords associated with each measure of the melody. We pass the chordal accompaniment and the melody into the Music21 API, converting the note representation we have into the standardized MIDI file format, which we provide as a downloadable executable to the user. They can take that, they can edit that, they can take that into GarageBand and make tracks out of that. In addition, we take the MIDI and using the FluidSynth API, convert that to a WAV file, also downloadable, and also they can listen to that through our front end. Now let's take a look at the core model. We operate with the underlying assumption that we can probabilistically select the next note, given that we know the distance from the previous to the current note. To explain what I mean by distance, there's 7 notes in the scale. Each can be assigned an index from 0 through 6. The distance between notes is simply the difference between scale indices. On the right, you'll see a full probability transition matrix for the pop genre. On the x-axis, we have the distance between the previous and the current note, a known value. Once we know that, we can select a vertical column out of the matrix, giving us a probability density function for the distance from the current to the next note. We believe that we've developed a unique and valuable model. If you look at the left, you'll see probability density functions representative for the classical and pop genres. You'll notice a high degree of non-uniformity or low entropy, indicating that we're modeling a meaningful signal here. In addition, we notice nuanced differences between the PDFs, demonstrating our ability to differentiate genres.
Once our model and product were complete, we knew it was time for beta testing. We received primarily positive feedback, with most users saying that at least 30%, a third of the songs, were good enough so that they could imagine a full composition surrounding that melody. Additionally, they provided other supportive feedback that we incorporated into the live demo that you saw today unknowingly. Here are 2 charts taken directly from the survey, which we believe show market potential and product viability. On the left, we have a chart which shows that at least almost 2/3 of people think that melody is the key pain point when composing, which shows a real need for our product. On the right, we have an 85% willingness to pay at least some amount for this product, which shows real profit potential in many different forms, such as straight-up payment, subscription, or use-based payment. With that, let's go into the entrepreneurial potential. So over the course of the year, we have all looked into IP options, such as copyright and patent, and we did so through Penn Law. Once our product is protected, we want to explore the further potential of our product, such as looking into expanding the current program into other complex genres, such as jazz or blues, and the creation of full songs. Additionally, there are other product options, such as a computer application, which will allow for offline use, and a mobile application, which could randomly generate ringtones that you could hear different every time, which would be kind of cool. Finally, we can go into the capability of profit or monetization. And from the slide above, we know that there are multiple paths to this approach that people could potentially be willing to take based off of the survey results. Additionally, if a licensing option occurs, we'd be happily willing to consider that. Thank you for listening to our presentation. Are there any questions?
Yes?
Yeah, so clearly this is targeted at people with some training in music or some knowledge of composers. Have you thought about making it accessible to everyone by allowing you to listen to music that you like and pulling out and say, hey, make me something like this?
Actually, yes. We're already exploring interfacing our website with a MIDI keyboard, and we're actually looking into a person being able to play a song and it dynamically creating a probability distribution function unique to that specific user. So if the user wanted to play his songs he or she liked, then she might be able to extremely tailor it down to being what they want from the product.
Right, but actually, what if you don't play, right? So give it
They could sing it.
So the main point here is that we're trying to create something different from the current market. And
something that does this now?
there are already things that just, like Google Magenta, it just creates songs. And that's all it does. It just takes in a large testing set and then creates a song originally. But what we wanted to do was create something that is very different from Google Magenta in the sense that it fulfills a different need.
Right, Google Magenta specifically cuts the creator out of the process and focuses just on music generation, but we want to include the composer in our process, assisting them so that we're not eliminating the human creativity that is involved with music generation.
To add to that too, two things. So one, Google Magenta is not available to the public. So this is not targeting composers, it's simply a theoretical project. In addition to that, we are targeting amateur composers primarily, not professionals. So the entire design here was with the idea of really abstracting and simplifying the process as much as possible so anyone with zero theoretical knowledge could compose.
Yes?
Based on what you just said, that anyone with zero theoretical knowledge can compose, have you received any backlash from composers who feel like this is devaluing their own creativity?
So I can actually answer that. So with the survey, it wasn't included here, but we had a question of how much composing experience do you have? A vast majority of the responses were a little or equal to a hobby amount. And we found that that was extremely positive. As you saw, this was the survey results from that market. We actually also surveyed professional composers, and we saw an extreme disinterest in this project, which is why we've tailored our target market towards the amateur composers, which is a larger market anyways. Yes?
So the composer uses your system, and it turns out to be a big hit. Do you have any person says it was all due to Ripple? Do you have any?
So, do you want to answer? Yes, we have been speaking to Penn Law about this. Our primary concern in the beginning was, what if we create something that infringes on copyright? And they said, as long as there is a disclaimer on the website that says that the user has full ownership of everything that is created by this website, then we're safe, according to Penn Law.
So we are not trying to replace them. We are trying to give them recommendations, and it's the same process. Whether or not they would use us, they would have full ownership of the product itself. So it's on them to recognize if we spit out Lady Gaga, for example, which hasn't happened, although we have spat out the Nationwide theme song once, which was very interesting. Yes?
Just going into the data that you use to
Yes.
create the melodies, are you using existing pop songs? Is that a likely event that happens?
I can
in terms
talk
of
about that.
what
Sure.
underlies the data?
Right, so what we're doing for Pop and Classical, we pulled 100 representative songs from each genre. We generated the MIDI files for those and analyzed the data. However, we're not presenting to the user any connection between those songs. They can't select, like, I want to generate a probability matrix out of these select songs. Because of that disconnect, we don't have an issue of, oh, there's too much of a similarity to a certain song, there's too much of a legal connection between the two.
Basically, our discussion with Penn Law said that the more songs we use, the less likely we would actually create a song that's similar to them. So it's actually safer to use a larger sample size.